Welcome to all of you. In this session, we are going to discuss about the timers of 8051 microcontroller. So in 8051, there are totally two timers, timer 0 and timer 1. So these can be used as either timer or as counter. If we make use it to count the time delay, then we call them as the timers. If it is used as an event counter, then we are going to call them as the counters. Anyhow, we can configure them either as a timer or as a counter. So both timer 0 as well as timer 1 are 16-bit wide. So as per 8051 architecture, 16-bit we cannot load them directly. Therefore, that 16-bit can be divided into two parts, two 8-bit parts, that is TL and TH. TL is the lower 8-bit and TH is the upper 8-bit representation. So this is a representation of a 16-bit timer registers. So the lower 8-bit, this is timer 0 TL0, upper 8-bit timer 0 TH0. Similarly, it is applicable for TL1, TH1 of the timer 1. So as we can observe, the 0 over here that indicates this belongs to timer 0 and 1 over here indicates this belongs to the timer 1. The timers are controlled by using two registers, the TCON register, that is timer control register, and second one the TMOD register, timer mode control register. Among these two registers, TCON register is bit addressable, whereas the TMOD is byte addressable. Now let us go through each of these registers. First one, the TCON register. So this is known as the timer control register. So using this TCON register, we can control both the timer 0 as well as timer 1. So this is the 8-bit TCON register. In this complete register, so which are all having the 0 representation. So like this, IT0, IE0 like this. So these all belongs to the timer 0. Whereas the 1, as you can observe over here, IT1, IE1 like that. So TR1, TF1, these belongs to the timer 1. So based on the requirement which timer we are configuring, so we are going to make use of set or the reset of those particular bits. So let us have in general meaning of this. So starting from bit 0 up to bit 7, just a view of it. IT0, IE0, IT1, IE1, TR0, TF0, TR1, TF1. Let's have the basic meaning of these things. What are the 4 bits of timer 0 we are having? Same for timer 1 also we are having, and their meaning remains the same. So let's have a general meaning of that. TF stands for timer overflow flag, TR stands for timer run control bit, IE stands for external interrupt bit, IT stands for external interrupt type bit. Now let us go through each of these things individually. Now starting with TF1 and TF0, that is timer overflow flag. It is applicable TF0 for timer 0, TF1 for timer 1. So this bit will be set equal to 1 when timer 1 or timer 0 overflows. So that means during the counting operation, if there is a rollover from the highest value to the 0, then automatically this bit is going to set. It will be cleared when the processor executes the ISR, that is the interrupt service routine, after the overflow, and these are the interrupt service routine address applicable for timer 1 as well as for timer 0. Next is TR1 and TR0, timer run control flag. So this will be set equal to 1 when timer starts counting. Either it can be in the timer mode or in the counter mode. So whenever we want to perform the counting operation, to start the count or continue with the counting operation, we have to set this to 1. Until this bit is equal to 0, the counting will not happen. Therefore, so in the program, we are going to set this equal to 1 so that the counting operation can start. So it will be clear to 0, halts the timer, does not reset the timer. Remember, So whenever it is 0, timer will not operate, timer or the counter will not operate. It will be in the halt condition, but making this TR equal to 0 will not reset the timer. So these bits are totally controlled by the software. IE1 and IE0, external interrupt bit. This will be set equal to 1 when 8051 receives an interrupt on INT1 and INT0. Any of these two is applicable. So it will be cleared to 0 when it executes an interrupt service routine. So this is for INT1 and INT0. The addresses are given over here. And this concept, this IE1 and IE0 is not applicable for timer operations. Whenever the counting mode we are operating, then INT1 and INT0 we can make use of that. At that condition, these two are applicable. IT1 and IT0, external interrupt type bit. So this is going to control the triggering of the external interrupt. If it is set equal to 1, then INT1 and INT0 must be negative edge triggered. If it is set equal to 0, then INT1 and INT0 are low level triggered. So this is all about the TCON register. Now let us get into the TMOD register. So this is timer mode control register. So in this we are going to have total 8 bits, as we can observe over here, total 8 bits, of which the lower 4 bits belongs to the timer 0 control operation, mode control operation, and the upper 4 bits belongs to the timer 1 mode control operation. So as we can observe, the category of these 4 bits remains replicated for timer 0 as well as for timer 1. But based on the bit position, it is applicable for timer 0 as well as for timer 1. With respect to operation, there is no variation with respect to the bits. Now let us take a look at what is going to happen over here. Now C bar T bar, which is present both in timer 1 and timer 0, that's the first thing over here. C bar T bar, it is counter bar timer bit. So whenever we want to configure this counter, this timer as a timer or as a counter, then we are going to make use of this one. So if it is set equal to 1, then it is going to act as a counter. If it is clear to 0, then it is going to act as a timer. So again repeating, remember, so if we are operating with a timer 0, then if we are going to set this bit equal to 0, then this is a timer. If it is being set equal to 1, then timer 0 is going to act as a counter. Right? The same is applicable over here also. So whichever the timer we are using, based on that corresponding bit, we have to make it either high or the low. And also remember, this is not bit addressable. The TMOD register is not bit addressable. The next one is the get, which is present both in timer 1 as well as the timer 0. So this is get enable control bit. When it is set equal to 1, timer is controlled by the hardware, that is the external INT signal. When it is clear to 0, timer is independent of the interrupt signal. Then M1 and M0. So M1 and M0 present both in timer 0 and timer 1. This is called the mode control bit. So we will have a detailed discussion about this mode control bit in the next lecture. Thanks for joining.